Welcome back to this next video in which we are discussing valvular heart disease. Okay, so let's continue going through the anatomy of the heart valves. We've just done the tricuspid valve, so the next one up is going to be the pulmonary valve. So the pulmonary valve is between the right ventricle and the pulmonary trunk. And just like the tricuspid valve, it's going to consist of 3 separate valve cusps. So the first thing I want to do is show you the positions of these 3 cusps. Now, unfortunately, the anatomy of the pulmonary valve is not as simple as the anatomy of the tricuspid valve. The cusps are not as simple shapes as they were in the case of the tricuspid valve. If you remember back to the tricuspid valve, all the cusps were beautifully flat and the tricuspid annulus was beautifully flat. Whereas in the case of the pulmonary annulus, it's not beautifully flat. Instead, we have these commissures, and those commissures are going to make the shapes of the cusps far more complicated in the case of the pulmonary valve. So it will take me a little bit of time to explain to you the shape of the pulmonary valve cusp, but bear with it. I hope by the end of it you will understand what shape these are. So I'm going to try and draw it straight onto this picture up here. Remember, we have this commissure here, and this commissure here. And the 3 cusps are going to be demarcated by those commissures. So it's going to be just like this. These are the 3 cusps in the case of the pulmonary valve. You've got one here, and one here, and they're called very sensible things. The one right at the front is called the anterior cusp of the pulmonary valve. The one on the left here is called the left cusp of the pulmonary valve, and the one on the right here is called the right cusp of the pulmonary valve. So those are their names. We have the anterior cusp of the pulmonary valve, we have the left cusp of the pulmonary valve, and then finally we have the right cusp of the pulmonary valve. Now, that picture that I've drawn you here doesn't quite show it to the degree that I would like to communicate this to you. So I'm going to draw another picture of it out here. Firstly, I'm just going to draw a better picture of what I've got there, where I'll draw what it would look like from the top. So here we go. Here is the pulmonary outlet here, and we're going to have our 3 separate cusps in these positions. Here is the anterior one, here is the left one, and here's the right one. Now, the cusps unfortunately are not flat shapes. If you think about it, they can't be flat shapes because there's a commissure here. They're going to attach to the pulmonary annulus, and there's a great big commissure here. So the shape has to be disturbed by the commissures, basically. It has to respect the commissures because the cusps are going to attach to the commissures. So what I'm now going to attempt to do is draw you a picture of one of these cusps from the side, so from this sort of angle here. So we'll do the left pulmonary cusp. So let's say we've got, here is one of the commissures of the pulmonary annulus, and here is another commissure, like so. Now let me show you the cusp that's going to be suspended in between these 2 commissures, attached to these 2 commissures. So it's going to be attached to this wall of this commissure, this part of this commissure, and this part of this commissure. So the part that's to the right on this commissure and the part that's to the left on this commissure, as you look at it. Okay, so it's going to be like this. You're not just going to have one simple flat piece of connective tissue. Instead, you're going to have 3 separate surfaces, and it's going to be like this. So here are 2 of the surfaces, and then you're going to have a floor. So let me colour the 3 separate surfaces in different colours. So here's one bit of connective tissue that makes up the valve. Here's another surface of this valve cusp. And finally, here is another surface of the valve cusp. So these cusps are very complicated shapes. There is a corner there, and you have these 3 separate surfaces that make up the cusp. This is just one cusp suspended in between these 2 commissures, and then you can go on because this side of this commissure will be then involved in the making up one of the surfaces of the right cusp, and this side of this commissure will be involved in making up one of the surfaces of the anterior cusp, and then you can imagine it going all the way around and creating these 3 cusps that sit next to each other. Okay, and this means that there is a space within the valve cusps. If I was a little man standing up here, I could go into this sort of space for each of the valve cusps. I could go into this space for the left valve cusp, I could go into it for the anterior one or the right one. And this space will be bounded by this wall, this floor, and then the final wall will be the wall of the pulmonary trunk, which will be here. Just to orient you, remember that this is the pulmonary trunk at the top here, and this is the right ventricle at the bottom. Now these spaces have a special name. They are known as the sinuses of Valsalva. So these are called the sinuses of Valsalva of the pulmonary valves. So the pulmonary valve cusps have this far more complicated shape than the tricuspid valve cusps, which were just flat. However, the structure as far as the different connective tissue layers are concerned of the pulmonary valve cusps is very similar to the structure of the tricuspid valve cusps, so that is at least something that is preserved. However, what you'll see is that it is actually as though this has been rotated round. So let me now talk you through this. So what we're now going to do is take a little sample of one of these valve cusps here and have a look at the different connective tissue layers that make it up. So let me orient you. Here are the two boundaries. Above here will be the pulmonary trunk, and below here will be the right ventricle. Okay, and of course both sides of the valve cusp will be lined by endothelial cells, so I'll start by putting those on. So here is an endothelial cell, here's another endothelial cell, another endothelial cell, and another endothelial cell. Okay, right, and of course those will be sitting on a basement membrane, so just for completion I'll put in the basement membrane here. There's the basement membrane at the top, and here's the basement membrane at the bottom. Right, so now let's discuss the connective tissue layers. So you have the same three connective tissue layers. You have the fibrosa, a collagen layer, you have the spongiosa, a glycosaminoglycan layer, and you have the elastic connective tissue layer. However, they are in different orders. So remember, when we were looking at the tricuspid valve here, at the top you had the atrialis layer, then the spongiosa layer, and at the bottom you had the fibrosa layer. Now, in the case of the pulmonary valve cusps, it is at the top that you're going to have the fibrosa layer, underneath that you'll have the spongiosa layer, and underneath that you'll have the elastic connective tissue layer. So let me draw this on. So it's almost as though it's been rotated round, and this still makes sense because, remember, the fibrosa layer faced into the chamber where the blood was going. So remember, in the case of the tricuspid valve, blood was going from the right atrium into the right ventricle. So the fibrosa faced the chamber where the blood was going into. It faced the direction of movement of the blood. In the case of the pulmonary valve, the blood is going from the right ventricle to the pulmonary trunk. So again, the fibrosa is at the side where the blood is going into. So it is still making sense. So this layer here, which I'm colouring in purple or pinky colour, this is the fibrosa layer. Then underneath that you'll have the spongiosa layer, which I'll again do in this yellow colour. So this is the layer consisting of the mucopolysaccharide connective tissue rather than the collagenous connective tissue. So this is the spongiosa. And then finally, underneath the spongiosa, you'll have the elastic connective tissue layer. This time it's not going to be called the atrialis. Remember, in the case of the tricuspid valve, the elastic connective tissue layer was called the atrialis because it faced the right atrium. This time it's facing the right ventricle, so this time it's going to be called the ventricularis rather than the atrialis. So again, it all makes sense. Okay, right. So that is the structure as far as connective tissue layers is concerned of these cusps of the pulmonary valve. Okay, so to summarise where we've got to so far, we've seen that the pulmonary valve consists of these three valve cusps, an anterior one, a left one, and a right one. They have this strange shape creating these sinuses of Valsalva suspended in between the commissures. So it's all makes sense as long as you remember that the pulmonary annulus is not just flat, it has the commissures, and therefore the valve cusps have to have this stranger shape creating these sinuses of Valsalva for each valve cusp. So you have the left sinus of Valsalva, the anterior sinus of Valsalva, and the right sinus of Valsalva for the pulmonary valve cusps. And we've now seen the structure, as far as connective tissue layers is concerned, of these valve cusps. Now let me talk you through the function of the pulmonary valve. So of course what's going to happen is at rest, the natural position of the pulmonary valve is closed. So again, the separate pulmonary valve cusps are not joined together, so there is no fusion between the left one and the right one, or the right one and the anterior one, and the left one and the anterior one. If you were a little man, you could squeeze your way in between these places where they're up against one another. However, in the resting position, they are up against one another like so. And I think I'll try and show this to a little bit of an extent. So I'll try and draw a picture where we're looking at the full valve in a 3D sense. So here is the valve like so. There's the anterior one at the front there, and here are the posterior to the right and the left ones. And here would be the sinuses of Valsalva. So in the resting position, they are like this, where they're up against one another, and therefore the outlet is closed. Then, when the right ventricle contracts, so here's the right ventricle, when it contracts, pressure inside there will mount up, and what will happen is the valve cusps will get pushed upwards. So I'll show this. So all of these valve cusps, here's the right one, the left one here, and then the anterior one at the back there, all of them will get pushed upwards, and that will open up these spaces here. You'll open up spaces, and then the blood in the right ventricle can be ejected into the pulmonary trunk. Then, when right ventricular diastole occurs, then what will happen is the blood in the pulmonary trunk will want to try and get back into the right ventricle, and to stop that from occurring, the blood will go into the sinuses of Valsalva and push the valve cusps downward, and that will force them to close. It will close them up. And they can't really invert in the way that the tricuspid valve cusps could invert, because of the way that they have these walls. You can imagine it's just not really possible that they can invert. I hope your visualization is up to imagining that that can't actually happen because of the fact that they have these walls that are all going to be pressed up, and therefore it's not really possible for them to invert. So they don't need papillary muscles. Indeed, there are no papillary muscles stopping them from inverting. They just don't invert normally. Of course, in pathological circumstances, they can end up not closing correctly, but we'll go on to that later on. Okay, so that's the pulmonary valve. Let's now go on, and I realise that I've just put pulmonary valves. It should just be pulmonary valve. There is, in most people's body, only one pulmonary valve. So I'm just crossing that S out. Okay, so let's now go on to the next one. So we'll go on to the mitral valve next. And this is going to be very similar to the tricuspid valve. So it's much more simple to imagine the structure of it. So mitral valve. And remember, the mitral valve has another name. You can also call it the bicuspid valve, and it's the valve in between the left atrium and the left ventricle. So the bicuspid valve. And of course, finally, you could also call it the left atrioventricular valve if you wanted. Right, so this has just two cusps this time. However, as we'll see, one of the cusps can be thought of as being made up of three separate bits, which are known as scallops, but we'll come on to that in a moment. So it has two cusps, and these two cusps are an anterior one, so there is an anterior cusp of the mitral valve, and then a posterior cusp as well. So there is a posterior cusp of the mitral valve. So let me now draw these onto our picture up here. So the way it goes is like so. Here is the anterior cusp, which is much smaller than the posterior cusp, and then the rest of that is going to be made up of the posterior cusp. However, the posterior cusp is split up into three separate bits, like so. So there are little cuts in between these three separate parts of the posterior cusp. So all of this is the posterior cusp. So this is all the posterior cusp of the mitral valve. However, there are little cuts there, separating it up into three separate bits. One here, and one here. And these are called the scallops of the posterior cusp of the mitral valve. So let me go down here and we'll talk about the names of these. So, the posterior cusp, now change colour. The posterior cusp can be split up into 3 scallops. One is anterolateral, so you have the anterolateral scallop, as it's called, of the posterior cusp of the mitral valve, and scallop is spelt like so, S-C-A-L-L-O-P. So you have the anterolateral scallop, and that, of course, is this one here. It's antero and it's lateral, it's away from the midline. So that's the anterolateral scallop. I'll just label it up. So going in here, we'll label this one up as the, as the anterolateral scallop. Then you have the intermediate one here, and I'll write it out in full later. And then here is the posteromedial, because it's near the back and it's towards the centre. So those are the 3 separate scallops of the posterior cusp of the mitral valve. So writing out their full names, you have the anterolateral scallop, then the intermediate scallop, and then finally the posteromedial scallop. Okay, right, so the bicuspid valve, or the mitral valve, has 2 cusps. However, the posterior one can be thought of as being split up into these 3 separate parts: the anterolateral scallop, the intermediate scallop, and the posteromedial scallop. Right, it has again got an extremely simple structure, because the mitral annulus here is a nice flat annulus of connective tissue, and all of these cusps are nice simple flat pieces of connective tissue. And the structure of the walls of these cusps of the mitral valve will be exactly the same as the structure of the connective tissue layers of the cusps of the tricuspid valve. So just like this picture here, all you need to do is replace this now with the left atrium. So I'll do that. So this is now the left atrium, and this is now the left ventricle. So again, you have these 3 connective tissue layers. Again, the fibrosa, remember, recognize the patterns. The fibrosa is facing the way the blood will go, so it's facing the left ventricle. Underneath that, you have the spongiosa layer, which is the mucopolysaccharide layer. And facing the left atrium, you have the atrialis layer, which consists of the elastic connective tissue fibers. Okay, so just like the structure of the tricuspid valve cusps. Right. So next what we need to talk about is how this thing actually works. So again, in the resting position, the valve cusps will be in the closed conformation again. These lines that I've drawn here are cuts. If you were a little man, you could push your way through these cuts here. But in the resting position, they'll be in this position where the cuts are closed up. So they're nice and next to each other, and there's no way that the blood can get through. However, when the left atrium contracts, that will cause left atrial pressure to go right up. That will push the cusps downward, so the anterior cusp will go downward. All 3 of the scallops of the posterior cusp will go downward, and that will open up gaps through which blood can flow from the left atrium into the left ventricle. Upon left atrial diastole, so relaxation, what will now happen is, of course, the blood in the left ventricle will want to be trying to get back into the left atrium, because it's now at higher pressure in the left ventricle than in the left atrium. So what will end up happening is the cusps will get pushed back upwards into the closed position, and then they can't invert back inwards. Okay, they don't like moving in that direction. Then, when left ventricular systole happens and you get massive pressures inside the left ventricle, there's a real risk that then, even though these cusps don't want to invert, they might invert. So again, you have papillary muscles. So let me now talk about the papillary muscles of the mitral valve. So for this one, again, we have papillary muscles. In this case, in the left ventricle, you only have 2 papillary muscles, and they are the anterolateral papillary muscles and the posteromedial papillary muscle. So papillary muscles of left ventricle, we have an anterolateral one and a posteromedial one. So exactly the same discussion as what we had for the papillary muscles of the right ventricle. You have them as extensions of the ventricular wall, going upwards, and then having these chordae tendineae attaching them up to the free edge of the valve cusps. So the other one is called the posteromedial papillary muscle. So it's exactly like this picture up here, but now we're talking about the left ventricle instead, and you're only going to have two this time. So they're these extensions of the ventricular wall, and at the top they have these chordae tendineae going up and attaching to the free edges of the valve cusps. So where are their positions? Their positions are roughly like this, okay? So here, this is the posteromedial one, and it will have lots of chordae tendineae attaching to the free edge of the anterior and the posterior valve cusp. And here's the anterolateral one, and again, it will have lots of chordae tendineae going up to the free edges of the posterior cusp, all of the scallops, and the anterior cusp. Okay, so those are the papillary muscles, and again, when the left ventricle contracts, they will also contract. They'll pull downwards, the chordae tendineae will get a lot of tension in them, and they'll be pulling the valve cusps downwards and trying to prevent them from inverting into the left atrium. Okay, so those are the papillary muscles and the way in which we prevent inversion of the mitral slash bicuspid valve. And that's really the anatomy of the mitral valve finished. Let's now go on to the final one, which is the aortic valve, and this shouldn't take us long at all because it's exactly like the pulmonary valve. So we'll do it over here. The aortic valve is the final one we've got to discuss. And again, it's another one of these semilunar valves, so it has a complicated cusp structure compared to the tricuspid and mitral valve. It's got the same sort of cusp structure as the pulmonary valve. And again, we understand why that's going to be the case because look at those horrible commissures that we've got here. This has a complicated structure. It's not just a flat ring of connective tissue. Instead, we've got these commissures upwards. So the cusps are going to have to make do with this, and they're going to have their shapes affected by this. So you can predict exactly how this is going to work. You're going to have cusps like this. So you've got one here in between this front commissure and this left lateral commissure here, and then another cusp in between the front commissure and the right lateral commissure, and then another cusp in between these two. And you can probably predict the names as well. This one's going to be the left one, this one's going to be the right one, and this one's going to be the posterior one. So these are the left and right cusps of the aortic valve and the posterior cusp of the aortic valve. So the aortic valve, again, it has three cusps. Their names are the right and left. I'll just put R and L, and then also the posterior cusp. Okay, and if I was to draw a picture, it would look exactly like this, except a mirror image of this. So I will actually draw you a separate picture out over here. So here we go, like so. And here is the posterior one at the back here, and then we have the right and left ones at the front. So I'll just draw these divisions down, and if I was to draw a single cusp, it would be like this. So colouring in the separate walls again, here's the floor of this posterior cusp of the aortic valve. Here is one of the walls of this posterior cusp, the left wall, and then finally in not that colour, this orangey colour, here's the right wall of this posterior cusp, and those are the three walls. Remember, the back wall is not made up of the valve cusp, it's made up of the aortic wall. Okay, so again, very similar shapes of these three cusps. So, aortic valve, three cusps, a right one, a left one, and a posterior one. And they have this same complicated semi-lunar, meaning that they resemble part of a moon. Okay, so again, this is a semi-lunar valve, so its cusps are supposed to resemble bits of moons. And it's going to have the same sort of structure as far as connective tissue layers is concerned as the pulmonary valve. So exactly like this picture, all that we need to now change is we need to change this to aorta and this to left ventricle. But again, you'll have the fibrosa layer at the top facing up to the aorta, facing where the blood is going. The fibrosa always faces the direction of blood flow. Then underneath that you have the spongiosa, consisting of the mucopolysaccharides, and then underneath that, again, the ventricularis elastic connective tissue there facing the left ventricle. Okay, so that's the connective tissue layer structure of the valve cusp, and of course you'll have the endothelium covering either side. Now let's go on to how it's actually going to function. So its resting state will be in the closed position, like so. When you get left ventricular contraction, what that will do is it will raise the pressure inside the left ventricle, and that will push all of the three cusps upward, which I'll show on this picture. So again, you'll get this cusp going upward, this cusp going upward, and this cusp going upward, and that will open up these gaps. So remember, these are not attachments of the cusps, they're just the cusps being up against one another. So when they're pushed upwards, they'll open up gaps in between them, and that will allow blood from the left ventricle to go up into the aorta. Upon left ventricular diastole, then of course blood will want to return from the aorta into the left ventricle. What will happen is you'll get the blood going into the sinuses of Valsalva, and I missed out the fact that they're also called the sinuses of Valsalva. So you still refer to these hollow portions of the valve cusps as the sinuses of Valsalva, of the aortic valve this time rather than of the pulmonary valve. So blood will once again go into the sinuses of Valsalva, pushing the valve cusps down, and they'll go back into this closed conformation, preventing blood from going back from the aorta into the left ventricle. So that's the way in which the valve works, and it doesn't need papillary muscles to prevent inversion because of the design of this. It has much less chance of inverting than the tricuspid and mitral valves do, and therefore doesn't need papillary muscles. Okay, so that completes the discussion of the anatomical structure of the four heart valves. We'll have a break here, and in the next video we'll talk about heart murmurs, which are the sounds that you can hear on auscultation with a stethoscope pertaining to problems with the heart valve. So we'll go over stenosis and regurgitation and what stenosis or regurgitation for each of the four heart valves will sound like.